Hello, in this video we're going to be looking at matrix notation and algebra. Matrices are a little intimidating looking. They don't really look like math. There's a lot of brackets going on and stuff's all over the place, but they're not that bad. This correlates to section 6.1, Matrix Notation and Algebra, in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. We are going to be looking at a problem that one of the instructors has recommended. This is problem 35 in section 6.1. And so let's go ahead and look at that. And I'm going to do something a little different. I know in most of my videos we read the problem first, but unfortunately reading matrices problems not as easy as it sounds. So we're going to write as we go. So the question is, find a 2 by 2 matrix B such that the matrix A times the matrix B equals the matrix C, where A, whoops, I'm a little zoomed out, I'm going to zoom in real quick. A equals the matrix 1, -3, -2, and 4. And C equals the matrix 10, -7, -22, and 15. And again, matrices seem a little intimidating. They're not so bad. It's all about memorizing the formulas and how different algebraic things happen with matrices. So let's go ahead and look at that. And I think you'll find it's not so bad. I've said this in the past, but everybody has a different way of doing problems, and I'm going to show you my way. I hope it makes sense to you. I think you'll find it good. This is how I got through matrices. They're a little rough at first, so the first thing I like to do is we've written down what our two known matrices are. Let's go ahead and write down the matrix we don't know. And you're like, well, how can we do that? Well, we're just going to put random values in here. So I'm actually going to do x, y, z, and u. I ran out of variables, sorry. And then the next thing is we know that A times B equals C. Okay, so how do we do this? Well, matrix multiplication doesn't seem as simple as it is, but it's pretty easy. So let's go ahead and actually write it down. So A is the matrix 1, -3, -2, and 4 times the matrix x, y, z, and u. Okay, so how does that help us out? Well, now we can actually just plug in the formula. So there's a very specific way you do matrix multiplication, and the first way, I'm going to try to do different colors. It's going to take a little bit more time, but it's potentially a little better. So we're going to find this kind of pseudo matrix that exists between the two. And this is the matrix that isn't values, that's AB. So this is the matrix AB. And that sounds not as helpful as I was hoping it would be, but we're going to go for it. So the first thing we want to find out is this slot. And this slot, actually, I need it to be a little wider because this is going to be kind of big. So we're just going to, understand this is matrix. This is going to be a little bigger than we normally like. So to get this slot, first thing we do is we take 1 times x, and then we add -2 and z. -2 times z. Okay? So that's our first slot. That's not so bad. So what's our second slot? We're going to do this one in blue. So we're going to go and do the slot that's right here, right? So this is a 2 by 2 matrix. So this one is 1 y plus -2 u. You might be seeing a pattern. This is all about patterns. You just got to get familiar with them. And for our third color, it's kind of purple. So we're going to do this one. And this one is -3x. Are you seeing what I'm doing here? -3x. And 4z, so it's plus 4z. And then finally, for our last one, we're going to do orange. I'm running out of colors. We're going to do -3y 4u. So plus 4u. Okay, so you say, Anna, okay, so we made this crazy looking matrix, but how does it help us? Well, we got to remember that this is the result of multiplying the matrix A and B. And what does that equal? Well, that equals C. So we're going to go ahead and plug in the matrix, and I've got to move over. It's kind of hard to see everything, so at the very end we'll zoom out and look at it overall. So this is 10, -7, -22, and 15. So hopefully you've been keeping up with your finite class, and right before this, typically they go over solving series of equations with multiple variables, specifically 2 variables. And you know, I'm looking at this, and that's what it looks like. If you notice, I'm going to try to go red here. If you notice that this and this both have x's, they both have z's, and they correspond to this and this. So we can make those equations. That's what they are. So this turns into, and I'm trying to get everything, so 1 times x, and I'm just putting that in there so we don't forget that we've multiplied stuff together. 1 times x minus 2z equals 10, and -3x plus 4z equals -22. And we're going to go back to our red. We're actually going to go to, I don't know, a nice cyan. This one has a y and a u, and this one has a y and a u, and those correspond in -7 and 15, so that's 2 more formulas. That's 2 more equations that we can plug stuff into. So that ends up being, we're going to put them over here, because I like to just write them all down, and then we're going to go down the list and solve them. So it's 1y minus 2u equals -7, and that's -3y plus 4u equals 15. Okay, so this should be looking familiar at this point. If it's not, check out some of our other videos about solving series of equations with multiple variables. It's not so bad. So what we can do here is, let's go ahead, and again I'm going to highlight in a different color. Let's go ahead and solve for x. And then what we can do is we can plug that in for that x right there. So this should be pretty straightforward. So x minus 2z equals 10. X equals 10 plus 2z. So now that we've solved for x, we can go ahead and plug it in that x spot. So it's -3 times 10 plus 2z, and this is a z, doesn't look like a z, plus 4z equals -22. And you should notice all of a sudden all we have are z's, and we can solve this. This is basic algebra, just adding, multiplication. You can do this. So -3 times 10 is -30 plus 6z, so that's -3. Anna does, I make mistakes too. Everybody makes mistakes. It's okay. So what I did there is, it's -3 times 2, and that's -6. -6z plus 4z equals -22. And so, you know, this ends up being -30 minus 2z equals -22, and then we add both sides. We add 30 to both sides, and that ends up being -2z equals 10. Wow, I can't do basic math. Everybody makes mistakes. It's okay. So 30 minus 22, or -22 plus 30, is 8, right? And so that means z equals -4, because we've divided both sides by -2. So what do we do with this? Well, we can now plug this back in to our x. So what is x? So x equals, whoops, so we solved for x somewhere, and that was x equals 10 plus 2z. And so x equals 10 plus 2 times -4, and that is x equals 10 minus 8, x equals 2. And you're like, well, what does this do for us? Well, I'm going to scroll all the way back up, and I want you to remember that we didn't know what b was, but we set this up so we have x, z, y, and u. And so we now have this one done and this one done. We're halfway done. It wasn't so bad, was it? So let's go ahead and continue, and then we're going to put it all together at the end, and it's going to be glorious. Let's go ahead and do the same thing on this side. So on this side, again, we're going to choose a variable to solve for. We're going to highlight this in blue. We're going to do y. So let's go ahead and solve for y. So y equals negative 2u. Whoops. So I'm jumping ahead. Y minus 2u equals 7. That means y equals 7 plus 2u. And so now that we have this y, we can go ahead and plug it in here. So we're going to plug this whole thing right in there. So I'm writing stuff over and over again, and don't be afraid to do this, because if you make a simple mistake, the instructors want to give you credit. So, you know, the more information you put down, the easier it is for them to give you credit. So we're plugging in 7 plus 2u for y plus 4u equals 15. So, okay, let's keep on keeping on. So let's see. So it's negative 21 minus 6u plus why do I feel like I have something wrong here? I am backing up for a second. I do. This is a negative 7. So that's part of my problem there. Something didn't quite seem right. So negative 3 times negative 7 is 21. Negative 3 times 2u is 6u plus 4u. Everybody makes mistakes. It's okay. Equals 15. So let's keep on going. 21 minus 2u equals 15. And so negative 2u equals negative 6. U equals 3. Okay, so now what are we going to do? We're going to plug this u back into our first equation. So if you'll remember, that was y equals 2u minus 7. So that's y equals 2 times 3 minus 7. And that's y equals 6 minus 7. That's y equals negative 1. So how does this help us out? Well, we know we're going to go all the way back up here. I know it's getting kind of gross. We're moving all around. Sorry about that. We now know our y, and we now know our u. So let's go ahead and build our actual, thing. So B is the matrix x, y, z, u, which is the matrix. And so we have a value for x. What is our value for x? Our value for x is 2. Our value for y is negative 1. Our value for z is negative 4. And our value for u is 3. So let's zoom out and talk about what we did here. It seems kind of crazy, but it's not so bad. So what did we do? I'm going to go to my nice dark blue. Actually, we're going to go to purple. Kind of hard otherwise. So what did we do? The first thing we did is we wrote everything we know down. Then we made up this thing right here. We know it's a 2 by 2 matrix. We know that we don't know anything about it. We just know it's a 2 by 2 matrix, and there's 4 values inside, so we label those x, y, z, and u. And we know that the matrix A times the matrix B is equal to the matrix C. So we then wrote, and this whole thing is equal to AB. So we then wrote those out. So this is A right here. This is B, which we don't know. Then we went ahead and we figured out how each of these values would be done. And this is purely by memorizing the formula and how these things are constructed. And then we set up our values for C. So that's right here. This is C. And then we went ahead and we went down and we decided what our 4 different equations are that each have 2 different variables in them. And we solved. So first we solved for x right here. We plugged that back in. We got a value for z. We plugged that back into our first solving for x, and then we got a value for z, and we got a value for x, and then we did the same thing over here. First we solved for y, we plugged that in, we got a value for u, we plugged that back into the equation that we had used to solve for y, we got a value for y, and then all we did is we plugged the value for x, the value for y, the value for z, and the value for u into our matrix, and that gave us the answer. So matrices are a little intimidating. There's a lot going on. They don't look like math. There's numbers all over the place. But once you kind of get the idea of how they work together, multiplication I think is the hardest part of matrices. You won't have a problem. I know this. So do some practice, keep on working, and I know you're going to do just fine.